Yes, hi guys. Today I am talking about area of a plane curve under the plane curve. Okay, a portion of a plane area under the curve. Okay, plane area under the curve given. So here this is known as quadrature. What is quadrature? I'll just define. But before that, let me talk about these questions are taken from the student queries again. So after clarification of these questions, or when I'll solve these questions, then everything will be clear. So how to find out the area of a curve or under the curve, okay, between two ordinates or between two abscissas. Okay, abscess means by coordinate, by values of by coordinates or value of x coordinates. Suppose x equal to a and b, they are known as ordinates. If y equal to a and y equal to b, then between these two, these 2 points a and b, this they are known as abscesses. So in both the cases, okay, when the curve is okay, it's when there are curves, okay, between the x-axis and the two ordinates and the plane. Okay, this is one of the cases. Second case is when the curve is under the area under the curve and between the y-axis, okay, and two abscesses. Okay, x equal to suppose c and y equal to c and y equal to d. Let me take. So c and d. In this case, we will take. So there are two cases mostly in case of finding the area of plane curves. Okay, so plane curves in this case, area under the curve we have to find out. So what the quadrature? This is area of curves. Area of curves. This is known as quadrature. Why this is quadrature? In this case, there are two definitions here. What's the first definition? Let me define. The process of finding the area of a part of a plane curve or under the curve, a part of it, is the process of finding this area is known as quadrature. This is one of the definitions. Second definition says that area of a of a square, if it is equal to the area of a area of a plane curve, also, or under the plane curve, area of a square, or let me take area of a rectangle, or area of a four-sided figure under the plane curve, okay, which is part of a quadrature. Quadrature is quadrangle type, okay, four-sided figure. So if the area of a square or rectangle is equal to area of a plane curve, which is having four sides under the plane curve, this process is known as quadrature. Okay, so this is quadrature mean. So what the quadrature I'll just talk about, and how to find out the area under the curve if the curve is there and between the x-axis and the two ordinates, okay, and the area under the curve and between y-axis and two abscesses. Okay, these are the two processes I'll talk about. First, I'll take the process of integration, single integration. By the process of single integration, we can find out the area, or by double integration also, as we discussed in multiple area cases, okay, or multiple integration. In multiple integration also, I discussed about how to find out the area of plane curve. So okay, so this is the process here. So area of curves or quadrature is most important topic here. I'll take number of questions because most of the students have asked me questions. More than 32 questions are there. So this is 16 questions I've taken. The next lecture series also I'll take some more questions, maybe 16 or more than that, or 18. Okay, those questions are also to be discussed. So this topic will include a lot of discussion. Now let me prove that how to find out the area. The process of finding the area, let me define this. So definition. The definition of a quadrature, the process of finding the area of a plane, or part of a plane curve, of a part of a plane curve, a part of a figure under the curve, or of a plane curve, okay, part of a plane curve under it is known as quadrature. Okay, or Second definition is if the process of or this is definition, the process of finding area of a square, the process of finding area of a square, okay, finding the area of a sphere, the area of which is equal to the area of a figure under the curve to the area of a plane under a curve, a part of it, okay, plane under a curve, this is known as, this process is known as quadrature, So this is the quadrature here. Okay. Now let me find out what is the process then. How to find out the area. Let me now discuss about it. And what is the formula for finding the area of plane curve, or how do we find out the areas? Let me define that. So area of a plane curve, let me take y equal to fx. That now the process, area of a curve, of plane curve, area of a plane curve, let fx be y equal to fx, let me take fx be a curve, or y equal to fx be a continuous curve, continuous equation of a curve which increases as, or y increases as x increases, which increases as x increases. Y increases as x increases. Continuous means it is continuous function. Okay, when x increases, y also increases. So this is how function is continuous function. Okay, which increases as x increases. So it is an increasing function. Okay, then the area, of y equal to fx under the plane, I mean the curve, under it the x-axis and between the two ordinates, x equal to, let me take a, and x equal to b. We have to find out this area under the plane curve, okay, and the x-axis, and between the ordinates x equal to a and x equal to b. Let me draw the figure here. If there is a plane, let me take the plane like this. Okay, here it is. Let me draw the perpendicular here. If I take, this is suppose a point, draw perpendicular here, and this is at AB, and then another point, let me take here C, is a C point, this is D point. Okay, so this is the area under the curve which we have to find out what is the area of this curve ABCD or ABDC? Let me take D there and C here. Then it will be continuous thing type. This is D point, this is C point, no problem. This is x-axis, O origin, y-axis, y-dash axis, this is x-dash axis. Okay, now if I take P and Q, let me take 2 points are here. This is P point, this is Q point. Coordinates of Q are P. First let me take P, this is PXY. PXY are the coordinates, and Q, let me take another point in the neighborhood of P on the curve AD, okay, on the curve AD, x plus delta x and y plus delta y, okay. And if I draw perpendiculars from the point P and the Q on the axis of x, okay, and let me take them, these points as, and if I take this P here, that is good. Okay, and then, so these are the ordinates. Let me take this is P M point, this is N point, M and N. So these ordinates P, because this distance will be Y. P M is equal to Y. The Y is the abscissa. Okay, the value of Y is, this Y is PM. Okay, and Y plus delta Y is Qn. Now if I draw perpendicular from P to Qn, this is, let me take R here, and if I draw perpendicular from Q also on MP, which is produced here, means at S point, let me take PQRS, okay, and this is PQSR, or no problem. Now we have to find out the area. Now we see here that the area of MNRP or PMNR is smaller than the area PMNQ and is smaller than area SMNQ. So this area is bigger. We have drawn these perpendiculars here. Okay, this is the perpendicular. Alright, so now this distance, because the coordinates of x coordinate of Q is x plus delta x, so this distance is delta x. Mn is delta x. Here this is delta y. What QR is delta y? Undoubtedly, this is delta x. Okay, if I have to find out area of different plane curves, let me take, so what the area of this PMNQ area, if I have to find out, okay, then this is to be calculated from the total area SMNQ, the whole figure, minus the smaller area, this. So this area can be calculated. So that area, which is delta S, I'll just take that as delta S area, and this is S here. So PRMN or MNRP area, let me take, this is A area, and the area PMNQ is A plus delta A, or let me take S, and this is S plus delta S. This area in between these two is delta A. So when this Q tends to P, in that situation delta X tends to 0, delta Y tends to 0. In that limiting position, we will find out what is the area of this whole figure between this distance is A here, okay, because this is x equal to A, here x equal to B. So up to C point, this is B here, this ordinate is B. So OC is B, OB is A. Okay, from x equal to A to x equal to B, okay, area we have to find out. We have to just think about limiting position of this point. What is the area here? Okay, so this is, now let me solution finding out, or proof, let me take. This is the proof here. What is the area? How do we find out area of this ABCD? area of ABCD, if I have to find out, then we have taken these two figures. Okay, so after dropping the perpendiculars from this and that, so from this we see what is the distance. Here PM is, let me, PM, what I'm writing here. So PM is, let me take the briefing point. With this perpendicular we have dropped is just obvious, because S from QS is perpendicular on the line PM produced up to S. So this is QM. Okay, and then PR perpendicular drawn from P to QN, so it meets at R. This is also perpendicular. So this is the rectangle. Okay, so if I compare these two figures, I mean these three figures, first is this one, second is this, the smaller one, and bigger is this. Let area, which area? Okay, so this area we have to find out. Let area P M N R is equal to A, and area P M N Q is equal to A plus delta A. Let me take this is the area here. Okay, now we see that area of PMN or area PMNR is smaller than area PMNQ. PMNQ is smaller than area SM, or let me take MNQS, area of MNQS. MNQS is small. Now what are these areas? Let me talk about. So this area is A into delta X, Y into delta X, PMNQ, area PMNQ, area of PMNR is equal to Y length into breadth is equal to Y into delta X. Okay, and area of this is PMNQ is equal to Y plus delta Y, because Y coordinate of Q is Y plus delta Y into delta X. Okay, and while this area SQ, this value is Y plus delta Y. I'm sorry, this area is not of this but of SPQS, because this is the, I'm sorry, this area is of not PMNQ but this is of MNQS, because this is rectangle total. MNQS, this area is Y plus delta Y delta X. Okay, but so the difference of these two, now let me just define that. What is this area? MNQS is smaller than this, so but we know that these areas is smaller than this and that I have just talked about. So now therefore area of now these three figures let me talk about. So area of PMNQ, or let me find a difference here. So area of PMNQ minus area of PMNR PMNR, which we have considered A plus delta A. This PMNQ is A plus delta A. This is A plus delta A minus A is equal to delta A. So this is smaller area. Let me talk about this area. Is delta A. Okay, so delta A, if I just find out the area delta A, so this total area minus this area, because this delta A area is between this complete area, because this is equal to this, half of this. So total area is delta A. Let me find out, sorry. So delta A, sorry. Delta A here is so we see here that y, the difference of these two, this y is, this y distance is smaller than, okay, or we can say that y into delta x is smaller than delta A area, is smaller than y plus delta y into delta x. How it is? Now this delta A is this smaller area in between, and the y delta x is this smaller area, because this is between these 2 points. Okay, so PMNR is y into delta x, and SMN or MNQS area is y plus delta y into delta x. Okay, so this delta A, which is this smaller area, is lying between these two. If I divide this area, so y is smaller than delta A on delta x, is smaller than y plus delta y divided by delta x. Sorry, delta x is cancelled out from both these. This is only y plus delta y. Or if I just talk about difference of these two, y plus delta x, y plus delta y minus y, okay, is equal to this are taken to, or is less than, or is greater than, you may say, or is less than delta A on delta x. So y equal to, sorry, this is delta y only. So delta y is this value. Delta y, so this y plus delta y, here it was delta x, delta y equal to this, so y into delta y is equal to this. So y divided by this delta, so y is equal to delta x, delta A upon delta x. If I just talk about this is y only here, dividing by delta x is now cancelled out, so y plus delta y. Therefore y is equal to delta A upon delta x, or is smaller than, we can say, so then is less than y plus delta y. It means y is equal to delta x upon delta A upon delta x only. So that value, what do we see here? Therefore, the integration, so area of this will be sine of integration a to b, if I have to find out. So y into dx, okay, this is the area given to us, but y is delta A upon delta A, or dx, sorry, delta limiting position in limiting position of limits of delta x tend to 0, delta y also tends to 0, delta y also delta y tends to 0, delta y tends to 0. So y, in place of y, as we have just calculated that y is equal to delta A upon delta x, and this is equal to dA upon dx. Okay, in limiting position when delta x tends to 0. So this y, in place of y, we can substitute this. This is a to b. Okay, and this value is dA upon dx into dx, which is equal to nothing but a to b into dA. So this is area A after integration limits A to B. This is nothing but A at B, area at limit B, so equal to area when x equal to B minus area of ABCD. Okay, area of where A is area of ABCD, complete area on limiting position. So this tends to this, so total area is equal to, or we could say that A, B, N, Q, this area minus this area. Okay, the difference of these two is equal to this value. So this is area when x equal to B and area when x equal to A. This is equal to area of ABCD, area of ABCD in limiting position. Area of ABCD is equal to y into dx. Area of ABCD is equal to y into dx. So this is what we have to just calculate. I mean, we have proved that this area is between the x-axis, curve, and the ordinate x equal to A and x equal to B. X equal to A and x equal to B, and x equal to A and x equal to B, and this limiting position when this whole value is y. We have just calculated that this area is total dA, suppose. Now we could take AB and Q area, total area is, let me take A plus A, and then this area which was okay, this total area is dA, then this dA area when limiting position delta x tends to 0, delta y tends to also 0, then this line QN will, okay, and PM will coincide with AB. That means this area, limiting position area, will coincide with AB. So that means AB is, which is equal to x equal to A, and between CD is x equal to B. The area is to be calculated between these. So just we have to remember the formula only. This proof of this is not required. But mostly the questions are being asked upon this area. Now similarly, if the area we have to find out between the curve and the y-axis and the abscissa. Similarly, the area, let me just find out. Similarly, area between the curve, let me take x equal to f by, the curve x equal to f by the y-axis and the abscissa y equal to, let me take again A and y equal to B. If there are, or there is a curve here, let me take this curve is like this. Okay, and if this is the y here, A, let me take, and here it is y equal to B at this point. Okay, and if I take this point as this is A, okay, let me take this is B, C, or this is D, and okay, and at this y equal to B, and this is the curve here, and y-axis is this is y-axis, this is x-axis, O, origin. Okay, and then in that situation we have to take again a strip here, and this length will be delta y here, and here we will take P point, this is Q point. Okay, and coordinates of P and Q, x plus delta x, this is y plus delta y, and P is x and y. Okay, so this distance, okay, and we have to just find out this area, and in limiting position when delta y tends 0, delta x tends 0 also. Okay, in that situation, and here this is the curve. Here curve is y equal to, sorry, x equal to fy. Here curve is x equal to fy. this curve is x equal to fy. Between the curve y-axis and this is x-axis, y-axis, and the y-axis and the abscissa, this y equal to a and y equal to b. Between these two abscissa and the curve and the y-axis, we have to find out the area. So this area is given by area is equal to given by sine of integration. Here again, let me take, we can take the limits a to b, or between the abscissa, maybe taken as c and d, no problem, small c and small d, and this will be y into dx, y into, sorry, dy, to take x into dy. Here it is x into dy, x into dy, where x is fy, so we just substitute x fy into dy. With respect to y, we have to integrate this function. This is single integration. Okay, in case of single integration, we have taken the area of the curve between y-axis and the two abscissa. If there are two, no, let me change it to, if there are two curves given to us, area between two curves and two ordinates, let me take area if there are two curves given to us. So area between two curves, this is the third point we are taking. Point number 3 type of questions. Area between two curves, area between two curves. Let me take y equal to f1x and y equal to f2x. There are two curves here. So if I take the two curves, area between two curves, okay, area between two curves, x-axis and the two ordinates. So area between two curves, this x-axis and two ordinates, and two ordinates. What are two ordinates here? X equal to, let me take a, x equal to b. They are the two ordinates. So between two curves, two ordinates, the area we have to find out. Okay. Here no x-axis or y-axis included, but the two curves in between two curves. Let me draw the figure here. If there are two curves, let me take this curve.